Hello, welcome to Unit 5, Lesson 7, Proportions and Scale Factor. Okay, so personally I think this is a pretty straightforward lesson. There's just a couple things that we really have to make sure that we're doing in order to get the correct answer. Okay, so first off, scale factor is found by taking the new dimension and dividing it by the old dimension. All right, so that's all we're doing. All right. So let's go straight into examples. And so scale factor, I guess before we start that, are used for like taking like a life-size building and making a blueprint, right? Or taking a map, right, of a road and making sure that it's to scale with the real road. Or in this case, like in this first one, right, there's like a real life sandbox, but then she takes a picture of it. And what is the difference between those two, those distances, right? That's what we call scale factor. So number one, Tess builds a sandbox in a shape of a hexagon. All sides are 40 inches long. She then takes a photo and prints it. Now the sides are 4 inches long in the photo. What is the scale factor? So she went from life size to the photo. All right. So the new dimension is the photo's dimension, and that was 4 inches. Now it says it's a hexagon. That doesn't really matter. I mean, we can assume that it's a regular hexagon, which means all the sides are the same. But anyway, so the new dimension is 4 inches. Okay. The old dimension, or the life size, was 40 inches. So with that, we could reduce it, and we could reduce by 4, giving us 1 over 10, okay? But and I didn't write it on here, but on your actual practice, it says express your answer as a decimal. So this, as a decimal, whether maybe you know it by heart, which would be awesome, or if you don't, if you have a fraction and you want to convert it to a decimal, you take your numerator and divide it by your denominator, and then now you have the decimal version of that rational number, okay, or that fraction. So the scale factor would be 1/10. What that tells me is that the photo is 1/10 the size of the actual sandbox. Okay, number 2, I think this is number 3 from your practice. It says, what is the scale factor used to enlarge the rectangle? So if we're enlarging it, right, that means we're going from the little one to the big one, right? Enlarge means to get bigger. Okay, so the biggest thing that we have to remember when it comes to scale factor is that we're comparing for the same side in both shapes. Like, so in this case, this 5, that's the longer side, right? That one should be compared to this longer side, all right? And then this short side should be compared to this side, okay? So with that, if you remember from the first page, let's go back to that real quick. Hopefully you wrote it down. We take the new dimension divided by the old dimension. New divided by old. So our new dimension over here is 9. I'm going to compare the long side first, but I'll show you the same thing with the shorter side. And I'm comparing it to the old, which was 5. Okay? We could do the exact same thing with the other one. We can say 5.4 to 3. Now, with both of these, if they are proportional, then we should be able to set them equal to each other, cross multiply, and get the same amount. That's not our focus today though, okay? But that is a good thing to remember. So if I'm comparing for scale factor though, I'm going to do 9 divided by 5. And that gives me 1.8. Okay, so my scale factor is 1.8. Now, if these two shapes are proportional, I should get the exact same scale factor with the other sides. I should be able to do it with both. So I would have 5.4 divided by 3. Oh, there it is. It gives me 1.8 also. So that is our scale factor, 1.8. Now, that's another thing that we can think about too. Notice when let me go back to my first problem. With this one, we went from a bigger size to a smaller size, right? We went from the life size to the scaled size. And my scale factor was less than 1. So when that happens, so when you go from like a larger size to a smaller size, your scale factor is less than 1. When you go from a smaller size to a larger size, your scale factor will be larger than 1. Okay? And that's on your test too. So that's an important thing to remember. All right, let's try another one. This is from your quick check. Let me look and see what number it is because I didn't write that down. Number 2. So this is number 2 on quick check. Okay, what scale factor was used to create the copy on the right from the original on the left? So here's my second one, here's the original. So we're going, this is one, like this one, we're going from a smaller to a larger. Now notice both of these triangles, they're not facing the same way. That's okay, but we still need to figure out, well, what sides am I comparing? So with this one, here's my longest side on both of them. So those are the sides that I want to compare there. Here's my shortest side. Just make it a darker green or thicker green. Okay. And then here's this side as well. So we'll make blue and blue. Okay. So I want to make sure that I'm comparing the correct sides to each other. And remember, you take the new value and divide it by the old value. So in this case, as long as I'm comparing them correctly, I would have 36 compared to 18. The blue one, that's like my medium side, we have 30 compared to 15. And then the smallest side, we have 20 compared to 10. Okay? Now, if these two shapes are proportional to each other, they are scaled, then I should get the same value with all of these. Well, 36 divided by 18, well, 18 goes into 36 2 times. 15 goes into 30, or 30 divided by 15 is 2. 20 divided by 10 is 2. So my scale factor is 2, right? This one is twice as large as this one. That's what that's telling me. Okay? So hopefully that helps. Also, again, here's another thing where, right, we went from a smaller shape to a larger shape, and so my scale factor was over 1. If my scale factor had been 1, that means they're the exact same shape, same size, everything about them is the same. So that's a big hint with that as well. Okay? So if you go from a larger shape to a smaller shape, your scale factor should be less than 1. If you go from a smaller shape to larger, your scale factor is larger than 1. Okay? So hang in there and let me know if I can be of more support.